Start with an opener on page 7 in your notes packet. I'm sorry, on page 3 in your notes packet, and it's number 7. And it's given a line segment with an endpoint and a midpoint, and you're going to determine the other endpoint. So you're going to be working backwards here with the midpoint formula. Remember, in order to attain a midpoint value, you would add the endpoint value with another endpoint value and divide by 2 in order to attain the midpoint value. So think about that as you approach this to find the endpoint. Then afterwards, you're going to determine the length of the segment. So I want you to take a couple minutes to work on this opener, check with a partner. So go ahead and pause the video, and then you can go ahead and check your work back in a moment. When you press play again, you'll see the full problem done. So make sure you check with a partner first before you check. Okay, so welcome back. All right, so as you see, in order to find your x, y, and z for each of your endpoint values, as you work backwards, if you take an algebraic approach to that, you're adding your endpoints together, you're dividing by 2, and you're attaining your midpoint value. So I'm doing x plus 3 over 2 equals 1/2, and then you're just working backwards to find your x value, and you're going to do the same with your y and your z. So you end up with the endpoint -2, -6, 12. In order to find the length of the segment, you're going to take that endpoint in your original endpoint of 3, 0, -5, and you just use your distance formula. So your length, your difference between 3 and -2 is 5. Your difference between 0 and -6 is 6. And your difference between -5 and 12 is -17. But again, you're squaring it, so you can just go ahead and make it positive anyways. And I do want you to get an exact answer for these. So the highest perfect square in 350 is 25 with a leftover factor of 14. So that's how I got 5 root 14. So today we're going to move on to spheres in 3 dimensions or in 3-dimensional planes. So yesterday we had talked about the length of a segment. So we're going to go ahead and move on to the next page past number 8. And here we're going to talk about spheres. So remember back in when we were talking in two-dimensional, we had a circle, which was just x minus h squared plus y minus k squared equals r squared. And remember that your radius was the distance from your center to any point on your circle. So in the case of a sphere, it's your distance from your center to any point on the sphere. So your standard equation of a sphere is going to look very similar to your circle. The only difference is you have a third component. So where you had a center of HK, you now have a center of HKJ. And remember that your point in 3-dimensional, your typical point is x, y, z. So your standard equation of your sphere is going to be x minus h squared plus y minus k squared plus c minus j squared equals your radius squared. So it's going to look very familiar. And your center is your h, k, j. And then your radius is obviously your. So that is not much different, which is nice. It's the 3-dimensional look to it, and then the components and the question type of questions that come with it that we're going to have to study and look over together. So let's start with an example. We have a sphere with a center, and we have a unit of -1. So that means we're 1 behind, right? Because it's an x value of -1. So remember, when we think of our x values, we're positive x is in front, positive y is to the right, and positive z is above. So when we're doing -1, we're going behind, and then 5 to the right, 5. So we're about here, and then we're going to go 3 up. 1, 2, 3. So right about there is our center. So our actual center is we want to think about what octant this is in. That should be pretty easy to remember. So negative 1, 5, remember, is just our xy. So we can think of this as our quadrant 2. And because z is positive, it is indeed octant 2. If z was negative, it would be octant 6. Remember, because it goes 1, 2, 3, 4, and then 5 is under 1, 6 is under 2, and so on. So it's octant 2. So we're going to write the equation of the sphere in standard form, and that's just x minus negative 1, so x plus 1 squared, plus y minus 5 squared, plus z minus 3 squared, equals 4 squared, which is going to give us 16. So there's our standard form. Now here's a couple different type of questions. How far is the sphere from the, we're going to actually specify that to how far is the center of the sphere from the YZ plane. So when you think about this, let's go ahead and sketch our sphere before we look at this. So we have our center, and we can kind of ballpark our radius here because it's got our radius of 4. So when we do a sphere in 3-dimensional, we want to circle. Better circle than I can. And then kind of an oval this way. Give it a little bit of 3-dimensional look. In orbit around it. So we have our YZ plane. So our YZ plane, remember, is our wall, this wall right here, this up and down wall right here. So we want to think about where our x value is. And our x is negative 1. So it's 1 unit away. More specifically, it's 1 unit behind. And then because 1 is less than 4, because that's the radius, you want to think about the fact that this is indeed going to intersect this plane, because that'll come up later. So the sphere intersects the YZ plane. Okay, and it's going to intersect it at several points. In fact, it's going to intersect it at a whole circle, and we'll talk about that. So the XY plane is your Z value, right? So how far your Z value is, and your Z value is 3 units above. So that's 3 units. And again, 3 is less than 4. So we know that your sphere also intersects your XY plane. Okay. And then your XZ plane is where your Y value is 5. And your Y, and here you're 5 units to the right. So because you're 5 units to the right and your radius is only 4, since 5 is bigger than 4, the sphere does not intersect the XZ plane. So those are extra things to think about. So we already answered these questions. Does it intersect the YZ plane? Yes. XY plane? Yes. And then the XZ plane? No, right? Because it's 5 is bigger than those 4 units. Okay. So let's do a couple other applications. I want to make sure we're good on time here. We are going to probably have to be cut off here, so I'm going to make a second video if you want to see some of the other applications, because you are going to fill out an exit slip on your own here today. So if you just click on the second video link, I will finish up these last 2 applications with you before you do that. Okay.